Okay, for Form 4 biology class, I would like to explain the answer of your homework to you in this video. And for the second half of your homework, we'll come to question 19. Okay, please read the question. I guess you should have read this, right? Okay. I guess you should have read this. And they are asking about why. Okay, we calculate the ratio here. The mass of strip before and after immersion into this sucrose solution when it equals to 1.0. Wait. Okay. When it equals to 1.0, why is the potato tissue having the same water potential as that sucrose solution? For example, when there's a sucrose solution with this concentration, then it is having 1.0 in this ratio. So you have to explain the relationship in between. How are they related between the ratio? Oops. Between the ratio and the water potential. What does it mean? Okay, when the ratio is 1.0, so we can say that final mass equals to initial mass. Final mass equals to initial mass. Or in other words, you can say there is no change in the mass of potato strip before and after. And there is no net gain or loss of water. Imagine, let me draw a cell to you, a very simple one. A cell here, a cell here. There are, let's say, this amount of water initially, and later there's no change. After 1 hour, there's no change in the amount of water inside. Alright, there's no there's no gain of water, nothing. Get it? No gain of water, no net loss of water, no net loss of water by osmosis. So 3 marks in for this one. That's why no net gain, no net loss of water by osmosis. We can say, okay, this solution, this is an isotonic solution. By the word isotonic, we mean that this solution has the same water potential as the cell. This is an isotonic solution, and this solution has the same water potential as the cell. Okay, get it? Let me go to the next question. So based on the statement this here, you can say when the ratio equals to 1.0 here, when the ratio is 1.0, that sucrose solution actually is 7%. 7%. Okay? On the right hand side, I can amend something. This solution has the same water potential as the cell, or in other words, or in other words, 7% sucrose solution. 7% sucrose solution has the same water potential as the cell. Okay? So the last one, part B now. Describe the state of potato strip. By the word, the state of potato strip, you have to describe the tissue. The potato strip became flaccid. You can only use flaccid here. Flaccid, describing the cell or tissue. It's so soft, okay? Whereas the word plasmolize is not accepted in this question. Not accepted in this question because it is describing the cell only. Plasmolize is not accepted. Why is it plasmolized? Because 10% sucrose solution is actually a hypertonic solution. Hypertonic solution, it has a lower water potential than the cell. It has a lower water potential than the cell. And you can say that there is a net loss of water by osmosis because the water potential inside the tissue is higher than outside. Okay, the hypertonic solution outside has a lower water potential than the cell inside than the cell. Okay. So what would be the change in water potential of a fresh potato? Part C now. What's the problem? After storing it for a long time, why do we need a fresh potato for experiments? If it's not fresh, what happened? Because the water potential of potato will become lower because the water has evaporated. They will lose water and the water potential decrease. Okay, last one. Last three MCQ. So we have a potato with the hole inside. Inside the hole, we put some 10% sucrose solution. Outside the cell, we have some distilled water. Okay. So outside, let me take some notes. Outside, higher water potential. Whereas inside, lower water potential. And you can see the water will move in. Water will move in. So that's the liquid level inside rise because osmosis has taken place. Water moved from this. So what are the explanation for this for what you have observed? It's because water moved from distilled water through the cell membrane. Remember when we talk about the word osmosis? When we talk about the word osmosis, we're talking about the movement of water through the cell membrane. Through the cell membrane. Okay, so this part's 20D. 21. You can see when we put this cell in distilled water. Distilled water has distilled water has the highest water potential. Distilled water has the highest water potential. Right? And you are quite sure that water will move in. Water will move in by osmosis. So that the cell should become turgid, especially vacuoles. Vacuoles are enlarged. Vacuoles are enlarged in this case. So easy question. 21A. 22. 22 is a very difficult question. Okay, which of the following treatment will lead to a higher final level of sucrose solution? Let me take the first one. Okay, the statement 2. Statement 2. By using 20% sucrose solution inside. Okay, inside I use 20%. So this increase the difference in water potential between inside and outside. This would increase the difference in water potential between inside and outside. Therefore, you can see, okay, now, of course, the liquid level will go even higher, even higher. You wonder whether statement 3 is correct. It means that to take off all the potato skin so that water can move more quickly into the potato, right? This is only correct. It's only correct when statement 3 is only correct when in the first few minutes. 3 can only increase the water uptake. Statement 3 can only increase water uptake in the first 3 minutes. But remember, this experiment is carried out for 24 hours, 1 day. So later on, the liquid level will stop to rise. Water level stop rising in a short time. Water level stop rising in a short time. Which you wonder which one is the only factor affecting the final liquid level. Please read the question again. Which factor affects the final level of sucrose solution? As the only factor is the difference in water potential in between inside and outside. The only factor affecting the final water level, final liquid level. Okay, the only factor affecting the final liquid level is the difference, is the ultimate difference in water potential between inside and outside. So if you still have any question, you can feel free to ask me and by face-to-face lesson. Thank you and submit the homework tomorrow.